Good morning, PoA. Let's get started on this problem. That's my problem song. Do you like that? Alright, so this is all about input-output tables and rules. So we're going to try to employ all the different techniques we know to help us do this. One thing I want to kind of have you think about is that these have process columns. And if you run into a problem that doesn't have a process column, by all means, add a process column. Alright, so let's get to her. Um, The first thing we have to do is fill in the missing numbers. And I'll be honest, on the x side, that's kind of silly. That's obviously a 4. That's way too big. Hold on. U. Okay. So it's definitely going to be a 4. Here it's going to be a little bit tricky. We have to kind of piece together a pattern. So we have 16 to 20. Well, I'm seeing a plus 4. 20 to 24, I'm seeing a plus 4. So my guess is from here to here, that'll also be a plus 4, making that a 12. And that's just using the context clues I have around me. I don't know for sure that's right, but I got to go with it. And now I need to report a process. And again, I think if I report a process, I should be okay in terms of finding a rule. So one technique I know that we used in class that worked really well is going back to 0. So if I can kind of go back to 0 for my input, and go back to 0 for my output, that's going to reveal a huge piece of information about my rule. So check this out. If I'm going plus 4 going down, that's minus 4 going up. So 8 take away 4 should be 4. Now, the reason this is important is because if I think about how to go from 0 to 4, the only way to do that is to add at some point plus 4. The reason being is if you multiply or divide using a 0, it doesn't change anything. Like, you can't multiply by 0 and get anything but 0. I can't take 0 things and divide it and not get 0. So again, we're looking at a plus 4, and the 0 column revealed that. So if you don't have a 0 column, here's a hint: make one. Go back. If you can find this vertical pattern, then you can find the vertical pattern in reverse, and it could tell you a huge piece of information in terms of addition or subtraction. All right. So we know plus 4 is in our rule. So all we have to do is figure out, well, what's the other piece of it? So in other words, I have this number 1, and I have to do something to it so that when I add 4, I get 8. Well, I need to get a 4, so when I add 4 is 8. So my thought is I have to multiply this guy by 4. And it turns out that works, at least for this one. I don't know if it's worked for all of them, but it works at least for that one. Now, to be a rule, it's got to work every time. So I'm going to go ahead and test that. So we have this 2, 2, we have a 3, 3, we have this 4, 4, we have this 5, 5. So now it's just a matter of working this out and see if it actually panned out, so to speak. So we have this 4 times 1, which is 4, plus 4 is 8. It looks like it's working. 4 times 2 is 8, 9, 10, 11, 12. That works. 4 times 3 is 12. Plus 4 is 16. 4 and 4 is 16. Plus 4 is 20. And 4 and 5 is 20. Plus 4 is 24. So guys, we have this, and the reason why I always want to write the rule is because if you look at it, a lot of things are always staying the same, and just a few things are changing. So if you look at it, we always have this plus 4. We always have this 4 times. The thing that's changing every time are the numbers, but that's just a variable, and we can use, let's say, an x for that. And so we have our rule, y equals 4x plus 4. Again, it's all a matter of patterning. Like, if you can do a pattern, you can find a rule, no problemo. So we have y equals 4x plus 4. Now here's where the things get interesting. You have to use a rule to find the output when the input value is 20. Well, if you review your table, the input value is x. So what they're really saying is, can you find the y when x is 20? So we can do that using the rule. In fact, it's going to be pretty straightforward. It just becomes a substitution. And here's what I mean. We have y is equal to 4. Instead of x, I'm going to leave it open because we're told what x is. X is 20. So x in this case is 20. Now it's a matter of solving it, which we can do. We're pretty good at this. So we have 4 times 20, which is 80, plus 4. 80 plus 4 is 84, making the y value we're looking for is to be 84. So when the input value is 20, the output value is 84. Now here's where it becomes a little tougher. We have to use the rule we found to find the input value when the output value is 44. So once again, if we zoom out, we see the output value here is going to be the y value. Oops. So again, we're going to do an equation rewrite, leaving the pieces out that we know. In this case, we don't know the x, so it's still going to be 4x plus 4. We do know the 44, so I'll put that in for the output, which is y. So 44 is equal to 4 times a number plus 4. Okay, so here's the interesting part. 4 times a number plus 4 equals 44, which means that 40 has to equal to be 4 times a number. Meaning that if I took these 4 away, I got to take 4 away from this side too. Because that plus 4 will take it up from 40 to 44. So if I take them both from both sides, I'm just looking for a number times 4 times the number x to equal 40. Well, that's pretty simple. 4 times 10 is 40. So x in this case is going to be 10. So it's a little bit of backwards design. It's a little bit of working backwards to figure that out, but you can still use the equation to help your thinking. Now let's rinse and repeat, shall we? So we have to fill in the missing pieces and then find a rule and then use that rule to do some stuff, okay? So this is going to be 1. That's pretty simple. Here's a little bit more difficult. 10 to 7 should be a negative 3. And if this is a negative 3, that will take it down to 4. Minus 3 again. I do take it to 1. Minus 3 again, negative 2. Oh, excuse me. So it looks like the minus 3 going down is actually going to work out. Now to find a rule, I know I have good strategies in place. The big one being go back to 0. So if I take 1 back to 0, that means I got to take 10 back a step. And since I was always taking away 3 going down, since I'm going in reverse, I'm going to add 3, and it's going to be a plus 13. Now this is important because, again, the only way to get from 0 to 13 is plus 13. And if it works for one thing, it's got to work for everything, meaning that plus 13 applies to all spaces of my rules. So now it's a matter of just figuring out what to do to the input to get close enough so when I add 13, I get 7. And for this one, it might actually be easier to see on the 1 than anything else. So if I'm really going to add 13 and I got to end up at 10, I know that this number has to be a negative 3 because that's the only number it could be, so when I add 13, I end up at 10. So if that's got to be a negative 3 and I'm starting with a 1, the only way to do that would be to multiply by a negative 3. So I'm looking at a negative 3 times a number, well in this case our number is 1, plus 13 equals 10, and it does work out. So what we have to do now is to make sure it works for every single step of the table. Okay. I use green. Okay, so we'll put a 2, 3, or 4, or 5. We'll just test it. So let's test the one at the bottom. So negative 3 times 5, will that be a negative 15? So like if I have negative 15 in my checking account, which is probably accurate, negative 15, I say, well, here's a payment of $13. That means I still owe 2. Negative 15 plus 12 is negative 2. That works. I'll look at the 4, the one right above it. Negative 3 times 4 should be a negative 12. Add 13 to it. Well, it's going to take 12 to get us back to 0. 1 left, positive 1. Hey, this is working. Negative 9 plus 13 is 4. Negative 6 plus 13 is 7. And of course, negative 3 plus 1 is 13. So we do have a rule. Again, the rule writes itself, which is why the process column is so important. Which is why I keep saying, if you don't have a process column, add a process column. Like put one in, like rewrite your table. Because look at this. We have negative 3. We have a variable we'll call x plus 13. The rule writes itself. So negative 3x plus 13. So we have y equals negative 3x plus 13. Now we're going to repeat the steps we did before. We're going to use it to find when input value is 10, which means x is 10. So I'm still going to write y equals negative 3. I'll put a parentheses around the number or place. That number is indeed 10 because we were told that. So now it's a matter of just solving this out. Well, 3 times a negative 10 is a negative 30. And I'm going to add 13 to that. Grab your calculators if you need to, but it should be a negative 17 for the output. Now let's get out of here. New bar. Okay, so now we're going to do this for when the output value is 23. That's a y value of 23. So we're going to do a little backwards design. So we got a negative 23 is equal to, so negative 23 came from there, by the way. Then we have the rule is equal to negative 3. Wow, what's going on? Negative 3x plus 13. Okay? So when we multiply a number by negative 3 and then we add 13 to it, I get negative 23. So if I want to remove the 23 from this side, remove meaning subtraction, I also have to remove it from this side. If I remove from both sides, this will actually be a negative 36 is equal to negative 3x. Forget about the negatives. If I take 3 times the number again, 36, that number must be 12. Okay? And since the result is negative, and I already have a negative, that means my result is actually going to be positive. So I actually need x equals 12 at this point. Okay? That was a little more complicated. We're actually going to deal a lot more with that in the next unit. But for now, we just need you to do your best. Again, the big thing to pull out of this problem is that if you don't have a process column, for the love of all that is holy, please make sure you put it in the process column because it's going to help you guys out so much. All right, that's what I got for this one. I will see you guys next problem.